We all know that energy production is generally inefficient. We know that the conversion of one source of energy, like solar, to electrical power has not had a very high energy efficiency. In fact, probably one of the most efficient sources of energy is gasoline. And we have a very high ability to convert gasoline to other sources of energy, including electrical. It's a very compact source, so it's easily transported. On the other hand, it's still only 25, 30, 40, 50% efficient. So we have clearly there's some technological work to be done to convert one source of energy into electrical power. Uh, but there are other things that are also very appealing. One of them is not having to transmit the power over long distances, which often produces loss. And so we should be thinking, and I think we are thinking, about local power generation. Google, for example, put solar power panels up on all of its uh, central headquarters buildings, about 1.6 megawatts worth. That still only covers about 20% of our power requirement, however. And that's going to be true probably for some time to come. So local power generation will cover some but not all of your power requirements, or maybe the peak requirement is going to require drawing on remotely produced power. So I think we need to see both of those mutually supporting each other. One of the more interesting outcomes of making electrical cars or plug-in hybrid cars is that they are holders of power, holders of electrical energy. And you could imagine that the charged automobile becomes a source of grid power when the grid is experiencing excessive demand. And so you might wind up using the electrical power generated by an automobile or by its a small gasoline generator or by just the battery storage to become part of the power grid. Suddenly it becomes a reservoir. Uh, so I'm imagining that we have options now that we didn't have before. Now, as you mentioned efficiency, we've only talked about two potential problems, the generation efficiency and distribution efficiency, but there's a third one, and that's moderating demand. And for the first time in the history of power generation, we have an opportunity to have the power generation system interact with the consuming devices and telling them, for example, stop right now because I'm overloaded. We never had the ability to communicate with these devices before, and the only reason it's something we can contemplate is that it's possible to put computing power into devices that weren't normally thought of as having computers in them at all. So a washing machine or a water heater or any other power-consuming device could also be made somewhat intelligent. It could be reporting back its demands and needs. It could be accepting commands to say shut down for a brief period of time. Now, as you contemplate a system like that, the first thing you should think of is, well, how do I make sure that the 15-year-old next door doesn't shut down all of my entertainment equipment and everything else? So I need very high quality access control. So if I'm going to talk to all these appliances, and if they're going to accept commands from somewhere, we have to make sure that those are authenticated and that the only authorized parties have the ability to do that. That's technically feasible. So my sense right now is that in the world of electrical energy, we have the potential to make better use of electrical power than we did before on generation, transmission, and demand moderation. What will, of course, also be very nice is to move away from the consumable power generation, where fossil fuels and other kinds of things, to renewables. And this is another theme which I think I hope, will all follow on a global scale. We know that the same renewable resource doesn't necessarily work everywhere. Sunlight is wonderful where you have sunlight, but what happens if you're 6 months in the dark in the North Pole? So we can't use the same technology to deliver a solution in every location. That's okay. We need to be smart about which of the alternatives will work in various places. So I'm actually rather upbeat at this point about the potential for solving our energy problems because we have uh, the raw materials to do a much better job than we have in the past. And as we think about renewing our infrastructure in the 21st century, we have 21st century solutions to build, not 20th century repeats.
It's an excellent idea. As the subsidiary question to our presence here at LIFT this year, if you were given the equivalent sum of the carbon footprint that LIFT 09 is generating, what would you do with that sum? Roughly 1,000 Swiss francs.
That's a very interesting question. What you want is the highest possible leverage from that sum. You want to put it somewhere where it will do the most good. Rather than giving you a specific answer, I want to give you a kind of analogy for a moment. I want you to imagine that there is a big boulder and it's rolling down the hill. And you know that it's going to land somewhere, and it might cause a lot of damage. On the other hand, if you could just divert it somehow, it might do some good, or at least you could divert it away from causing any serious problem. So the question is, how do you do that? Well, it's too big for you to stand in front of it and say stop. But you notice that if you could get a pebble and put it in the right place in the path of the boulder would be diverted. I want you to think about the money that you're asking about as the pebble. And I want you to think about the boulder as the energy or the value that you want to divert. So my answer to your question is to say, where is there a flow of money being spent? How can I take my little pebble and cause that flow to go where I need it to go? And the answer may be this discussion, what you're trying to do in this discussion, because the pebble may be the ideas that people have for creating incentive for that money to go where it needs to go. Small example, persuading people that energy conservation and efficient production is important may influence their purchasing decisions. It may influence the decisions of product makers. It may influence the decisions of governments to invest in new kinds of power generation and distribution. So I think what I would generally say is, let's take that pebble and make it an educational tool. Let's use the leverage of education to divert a much larger amount of resource to where it will do the most good.
Do you have any particular area or any particular desire as to where you might start?
To where I would see, I think probably the most useful thing to do right now, the thing which would have the most immediate effect, would be to persuade manufacturers of all energy consuming systems to move towards higher efficiency and potentially reduce demand. So I would use that money to convene the manufacturers. Now, it's not going to be enough to simply beat them over the head with the idea. What you have to say is that there is a business model which benefits you, the manufacturer, as well as us as a society. So before you try to use this little pebble effectively, you have to be prepared with arguments that are of interest to the business world so that they see the value from their point of view of doing things this way. And that's not an easy task.